Hi everybody, I'm back again with another project similar to the one that we had earlier on. In this case, what we've done here, I'm trying to put as much information as possible on this small screen. So what I've done, you can see that it's changing, and if you put it close, I don't know if you can really see the. Okay, this might not be a good idea, but okay, let me explain how it works actually. So what I've done here, first of all, let's say I call it a flip-flop between screens. Okay, so what this one does, it's first of all, we use JsonArray to parse each asteroid entry in specific date. Okay, for example, we have the name of the asteroid, close approach date, missed distance in kilometers, and velocity in kilometer per hour. Okay, so I choose 5 of these asteroids that are coming around on the 17th of November. Information you get in via using an API key with the information from NASA NEO. It's NASA API project, which will have the information that you require, and you you parse it and make it set up for your screens, or with the serial monitors you can choose. I will show you how to do it just now. So the idea is to get this, to put each entry in the correct display. Okay, so let me see this now. In this case, for example, I must say, let me get a bigger lens. This is actually quite fun because, okay, so what do we see here? It's an asteroid name. In this case, it's 2016. Then there is one called 2017, and those are the dates, the velocity and the miss, how far it's from Earth when it comes around, and so on. And you can see that there is change, and you can change dates. You can put what happened on the 20th, how many asteroids are passing the Earth, close to the Earth on the 20th of November, for example, and so on. And you change the date, whatever. I'll show you how to change your date. The most difficult thing is to display on screen. You know what I mean? So in this case, we might need in future a bigger screen, okay? A larger screen so you can put more information. All right, so let's have a look at the code quickly. So this is the code to display on the OLED. Yeah, so same principle here. Remember to download because it's an OLED display, you need your Adafruit, GFX, and you need a SSD32H. Those are the library that initialize your OLED, like we did it here. Okay. Then, okay, sorry, there's something popping up here. Then you have you put your SSID here and your passwords as usual. Okay, now I've got here my API key. Please do not use this one. I will take it off and put your own API key. If you go to NASA API key, they'll give you the key and you can investigate. You can also go to NASA NEO, which is, it's a program that that does research on near-Earth impact asteroids. Okay, so and this is the how you set up your URL, okay. And in this case, the API key, I don't add them next to the URL, but I put them separately as a constant, okay. So here we go all right through, display the velocity and so on. And this is, it's how I explained earlier on, how it's going to do it. You're going to fetch the data from HTTP client, which begin the URL, which is initialize your URL and so on. Serial print request, and you go through all this process. Okay, so here's the same. It's different from the LCD, but it's the same principle. So we will have the missed distance, velocity, date, and name of the asteroid. One thing you can display, or you can also set up as lower time between each one. Between each flip-flop, you can put different time. So so that you can stay longer. So if we go this one here, let me show you. Sorry. Okay. Okay, so for example, to 2017, it's a name. How long does it stay? Then it's 2005, 2006, 2016. This is a name of asteroid. The extension, it's on there. The extension, it's here on the bottom. See? The QQ23, RP1, HC1 looks like. So W13. So it's the name, and then it's the close approach date, and then it's a distance, and the velocity. So what you can do here is to make it slower between screen. I choose 5, but you can choose 10, and you can let it run all day. You save your screen as well. Maybe you can do 1 minute per each one, or maybe half a minute each one, and carry on. Okay. So I think I'm gonna buy a bigger screen in future, so I can't do this with a small screen. All right, now this is going to show you another example. This is not connected to, it's something different. This is where you can collect the data, okay? So, for instance, here, if you go through, it's the same principle of the other one. Instead of showing them on a display, this will show on there we are. It'll show you on the serial monitor. Okay, so if you can see the serial monitor, but you can see this is all asteroids that are choose here. They were chosen. We have my API key here. Okay, then I put different dates. That's why I double quote this one. So you have a different date. In this case, I'm using 24th, 11th, let me see, 11/17. So you put a beginning date and an end date. Okay. So in this case, and then you need to put here the ID of the asteroids. Let me see where I put also here. see the end date, near Earth object. This is 2017, so they're all on the 17. Just looking. No, this actually does not give you in this case, sorry, the ID of an asteroid, because you choose it after you. In this case, I'll show all of them for this date. That we have this one. Asteroid name is 2024 VZ2, close approach date on the 17th, which would be in 3 days' time, and a missed distance from the Earth in kilometer, okay, but you can use, you can change it to AU, astronomical unit. Okay, it works with the distance from the Sun to the Earth, so they use astronomical unit, so you don't end up with a huge number. Okay, but astronomical unit very difficult to conceptualize in your head because you work in meterage and kilometers. I don't work in astronomical unit because it's too big and too far out. And then the velocity, which is 36,000 kilometers per hour. So this small body is traveling at 36,000 kilometers, almost 37,000. Okay, so here we are. We have another one. Now this one, asteroid name is 24 UM9. Close approach to the Earth, date 24/11/17, 3 days time. Missed distance to the Earth 362,000 kilometers, if I'm correct. That means that it's almost, it will pass behind the moon at the speed of 48,000 kilometers per hour. Okay, now let's go up a bit. Asteroid name UC5. Close approach date 24/11. Missed distance kilometers. Now this is much further away because it's 415,000 kilometers, if I'm correct. Let me see, I don't think a 4 million kilometer. I don't think 4 million kilometer, because 4 million kilometer, it's how many times the distance from the Earth to the moon. So the moon is about 380,000, if I'm right. Sometimes it's closer. So I should say 380,000. How many times stays in 4.1 kilometers? Probably it's about 12. It's 12 times the distance from here to the moon, if it's 4 million kilometers. So not sure about that. It looks like 415,000. Otherwise, I wouldn't call it close to Earth approach. But in any case, here's another one. This is a GM2 close approach date. That's the date when it's coming. This is all based on the 17, if you see on the coding here. And then you parse it and you put it on a different screen that you want. You can put it on a bigger screen, smaller screen. You can put it on OLED. You can put it on a LCD and so on, and you have fun. The whole secret of this is to have a flip-flop pages. You know, flip-flop pages that you can. Let me see if I can get closer. A flip-flop page that you can have one page every 30 seconds. So say 30-second page. Every 30 seconds, the page flip and show all the information. That could be done. Since you want as many as possible in a day, just to see how many rockets are flying close to the Earth today or tomorrow, you know. So it's just fun. And I think this is also a school project, very good. And it's educational because you understand the universe and what science is doing all about possible future impact of bigger rock, bigger asteroids. Okay, I think we cover quite a lot here. And as I said, the whole idea is to, you probably found that this is running on a ESP32, okay. But the other nice things is that you could use a Nokia screen, which is much larger, if you do have. It's more cumbersome because it needs a lot of pin, it needs a lot of pin to connect, and it's easy to make a mistake when there is more pins. But it'll display more, better, probably best is to get a bigger, large color screen, so that, yeah, let me put it bigger. Yeah. So, yeah, this is just a fun play with. Any case, just want to say thank you very much. Please give me a thumbs up if you like it. And if you have some ideas or other idea, please let me know. And have a good day. Thank you. Have a great day. Bye.